Hey everyone, in this video we'll figure out how to rationalize the denominator. So, why would we want to rationalize the denominator? So let's say if we had like 1 over root 2. On a test, you could put the answer as this, but it would probably be counted wrong because you could simplify this further. So how would we simplify this further? Or how would we rationalize the denominator? Okay, so usually there's two cases of this. There's one case where you just have the irrational number on the bottom, or there's another case where there's a whole expression on the bottom. I'll cover both cases in this video. So the first case is let's say we have just a number like 1 over an irrational number like root 3. We can simplify this by multiplying by the denominator to the top and the bottom. So we can multiply the top by root 3 and the bottom by root 3. Now, when we're multiplying by root 3 over root 3, everything stays the same because root 3 over root 3 is still 1. Because if you simplify this, that's still 1. So we're not changing the value of anything. So here, if we do 1 times root 3, we just get root 3 on the top. And on the bottom, we have root 3 times root 3, which equals root 9. And we know the square root of 9 is equal to 3. So our final answer would be square root of 3 over 3. Okay, so let me give another example of that. So let's say if we have 6 over root 3. How would we simplify this? Well, we'd simplify it by multiplying the top and the bottom by this denominator. So we'd multiply the top by root 3 and the bottom by root 3. So what would we get? On the top we get 6 times root 3. On the bottom we get root 3 times root 3, which is the same thing as root 9. And we know the square root of 9 is 3. Okay, so now we can actually simplify this further because 6 divided by 3 is 2. And we still have the root 3 from before. So this is equal to 2 root 3. See how we're able to get from 6 root 3 all the way to 2 root 3. It's so much more simple to write it as 2 root 3 than 6 over root 3. Okay, I'll give one more example of this. So let's say if we have 10 over root 2. And the teacher told you to rationalize the denominator. How would you do it? Well, you do it by multiplying the top and the bottom by root 2. So on the top we get 10 root 2, and on the bottom we get root 2 times root 2, which is the same thing as root 4. And the square root of 4 is just 2. And now we know 10 divided by 2 is just 5. So we get 5 square root of 2. Okay. Let me add a variable in this. Adding a variable doesn't change much once it's on the top. So let's say if we have like 10x over root 5. Well, still the same thing. On the bottom, there's only an irrational number. So we still use the rule that I told you guys before. So we multiply the top by root 5 and the bottom by root 5 as well. So on the top, we get 10x root 5. Or I should write 10 root 5 times x over root 5 times root 5, which is the same thing as root 25. And the square root of 25 is just 5. And now I could actually simplify this further because 10 divided by 5 is 2. So we get 2 root 5 times x as your final answer. Okay, now the next concept of rationalizing the denominator is when there's an expression on the bottom. Let's say if we had like 4 over 2 minus a root 3. How would we simplify this? Well, you simplify this by multiplying the top and the bottom by the denominator's conjugate. So just in case you guys don't know what a conjugate is, I'll tell you guys right now. So conjugate, what is that? Okay, so I'll give you an example. Let's say if we had like x squared plus 2. What would the conjugate of this be? Well, the conjugate of this would be x squared minus 2. The only thing that changes is this sign. If it's a positive sign, change it into negative. It's a negative sign, change it into a positive sign. So the conjugate of x squared plus 2 would be x squared minus 2. So let's say if we had 1 minus square root of 3. What would the conjugate of this be? Well, the conjugate of 1 minus root 3 would be 1 plus root 3. Since there is minus sign right here, we change that into a positive. Okay, so now let's get back into our example. Let's say if we had like 1 over 2 minus root 3. How do we simplify this? Well, we'd multiply the top and the bottom by the denominator's conjugate. Well, the denominator's conjugate would be 2 plus root 3. The only thing that changed is this sign. So we multiply the bottom by that as well. And now we can simplify this. So 1 times 2, what is that? Just 2. And then 1 times root 3 is just root 3, so 2 plus root 3 over. Now we have 2 minus root 3 and then 2 plus root 3. Now, how do we simplify the bottom? We have to use the acronym FOIL. FOIL means first, out, O-U-T, in, and then the outside, or last. So if we had 2 plus root 3 over 2 minus root 3 times 2 plus root 3, we have to do first. So that means 2 times 2, which is 4, out, so we do 2 times root 3, 2 plus root 3. Now we do in, so negative 3 times root 2, so we get 2 minus root 3. And then negative root 3 times root 3, so we get minus root 9. So now let's simplify this. We have 2 root 3 minus 2 root 3, so that goes away. Now we know the square root of 9 is just 3. So on the bottom we have 4 minus 3, which is equal to 1. So the top is still 2 plus root 3. Let me go further down. The top was still 2 plus root 3. On the bottom we had 1. So now the final answer is just 2 plus root 3. Now that might have been confusing, so I'll give you guys another example. Okay, so let's say if we had 10 over 1 plus root 2. How do we simplify this? Well, we'd multiply the top and the bottom by the denominator's conjugate. The conjugate of 1 plus root 2 is 1 minus root 2. So we multiply that to the top and we multiply that to the bottom. So now what do we get? So now we have to multiply the 10 into 1. So we get 10, and then 10 into negative root 2. So we get minus 10 root 2. And now on the bottom, we have 1 plus root 2 times 1 minus root 2. And now let's use the FOIL method to simplify the bottom. So we do the first part. So 1 times 1 is just 1. 1 times negative root 2 is negative root 2. Root 2 times 1 is just root 2. And then we do the last part. The root 2 times negative root 2 is minus root 4. So we can simplify the bottom further. We know negative root 2 plus root 2 cancels out. And the square root of 4 is just 2. And on the bottom we have 1 minus 2, which is equal to negative 1 on the bottom. And the top still stays the same as before, so we still have 10 minus 10 root 2. And we have to divide all this by negative 1, so in the end we get negative 10 plus 10 root 2. That's our final answer. Okay, I'll give you guys an example. You try it yourself, and I'll do it after you guys. Okay, so try this out. Rationalize the denominator. What would you get? Okay, I'll solve it now. So first, we have to multiply by the conjugate of the bottom to the top and the bottom. So that would be 2 plus root 3 on the top and 2 plus root 3 on the bottom. Okay, so now we multiply 6 into 2 and 6 into root 3. So we get 12. And then 6 times root 3 is just 6 root 3. On the bottom, we have 2 times 2, which is 4. 2 times root 3 is 2 root 3. Negative root 3 times 2 is minus 2 root 3. And then negative root 3 times root 3, which is minus root 9. And now we can simplify this further. 2 root 3 minus 2 root 3, positive 2 root 3 minus 2 root 3 cancels out. And now we know that the square root of 9 is just 3, so that goes into 3. So now what do we simplify to? We simplify all this to 12 plus 6 root 3 over 4 minus 3. We know 4 minus 3 is 1. And when we divide anything by 1, except for 0, it's always whatever on the top. So this simplifies 12 plus 6 root 3. And that's all. Those are mainly the two cases that you would need to know when rationalizing the denominator. I hope this helped. If you guys have any questions, put them in the comments below. And thanks for watching.